Hey everyone. So this is the first video lecture that we're going to be doing. We've kind of gone over ionic bonds, metallic bonds, and covalent bonds. And now we're going to get into chemical formulas. So what do we mean by that? A chemical formula, let me switch over here. You probably have seen it. So if I write NaCl, that's sodium chloride. That's a sodium atom and a chlorine atom that are together. This is two metals, so you know that this is, or a metal and a nonmetal, so you know that this is going to be an ionic bond. But you might also see something like magnesium chloride. Now, magnesium chloride has this little 2 here, okay? This little 2 basically means that there's 2 chlorines for every 1 magnesium. And this kind of makes sense. If you don't see a number there, you can kind of imagine kind of an understood 1. So this is an understood 1 that's there. If you write down sodium Na, you know at least one of them's there, right? So sodium has an understood 1, chlorine has an understood 1, magnesium has an understood 1. Chlorine here has 2, meaning that there's 2 of them. And you can probably imagine why this is the case. For sodium and chloride, sodium is going to be a positive ion, and chlorine is going to be a negative anion. And it's going to be 1 and 1, because sodium makes a 1 plus charge, and chlorine makes a 1 minus charge. And if you're confused on that, what kind of charges they make, you can always go back to the periodic table. Periodic table, all of these guys in group 1 are going to make ions that are 1 plus charge. And all of these guys are going to be 2 plus charge. Over here, this is going to be 1 minus, this is going to be 2 minus, 3 minus, and the noble gases, of course, are perfectly fine with an octet, and so that's just, 0. All right. So let's go through and talk about these ionic formula real quick. How do you go about and know how many are in each one? Like I said, sodium chloride is going to be 1 and 1, because you have 1 positive charge, and it's going to equal out to 1 negative charge. Java is trying to update. No, Java. Magnesium chloride, though. Magnesium, look here, magnesium is in group 2, so it's going to be a 2 plus charge. 2 plus. It means chlorine, there's going to be 2 chlorines around this 2 plus to equal out the charge. So that is what is going to be happening. You can always figure out how many of each thing you need, because there is no you can always tell how many of each atom you need, because it's always going to equal up the charge that is up here. You remember, like, if I did oxygen 2 plus, or 2 minus, rewrite this, oxygen 2 minus, this is an ion. You know this is an ion because this number up here is 2 minus. Same thing with chemical formula. Sodium chloride, what kind of charge do you see up here? There is none, so you know it's going to be neutral. 1 negative, 1 positive, neutral. No charge up here for magnesium chloride, and since this is 2 plus, you know there's going to be 2 chlorines there. Okay, let's go through and do a little bit of some problems here. So what we're going to do is I'm going to give you two different ions, a metal and a nonmetal. It's going to make a ionic compound. And we're going to go through and figure out what the little numbers are at the bottom. Those are called subscripts, by the way. Subscripts. Sub because they're below. So, calcium has a 2+ and chlorine has 1-. So, how many of each of these guys do we need in order to get a neutral compound? Well, we're just going to go ahead and write these guys. And if this is 2+, we know we're going to need 2 negatives for that. So CaCl2. Remember, we don't need to write Ca1 down, because if we wrote down Ca, you know there's at least 1. So there's that. Let's do this next one, number 2. So aluminum, 3+, and fluorine, -. Let's go ahead and do this. So we know there's going to be aluminum and there's going to be fluorine. What are the numbers going to be? Well, in this case, for 1 aluminum, we know there's going to be 3 fluorines for that. Aluminum and fluorine. 3 negative charges coming from the fluorine, and then 3 positive charges coming from 1 aluminum there. Okay. So there's that. This is where things start to get a little tricky. Aluminum oxide. So we have aluminum, we have oxygen. What are these numbers going to be? So we're going to want to get these guys completely balanced. We want as many negative charges as we do positive charges. So we know there's going to be at least 1. So I'm going to just go ahead and write 3+ here and 2- here. All right. Well, that's not going to work. That leaves us with 1 extra positive charge. So let's go ahead and add another oxygen to this. So 2 oxygens now. Now we have 4- and 3 positives. Still not good. Now we have 1 negative charge. 3 positives. Now we have 6 positive charges. 4 negative charges. Still not great. Add 1 more. So now we have 6 positive charges, 2 3+, and 1, 2, 3, 4, 5, 6, 6 negative charges. 6 and 6, we are good. So we have 2 aluminums and 1, 2, 3, 3 oxygens. And there you go. Now this is perfectly balanced. This is kind of the long way of doing things. I can tell you the shorter way is if you know the charges. So aluminum, you know, is going to be 3+, oxygen is going to be 2-. What you can do is just crisscross. So 2 negative, 3 positive, it's going to be 2 on the aluminum and 3 on the oxygen. If you do that, it works out perfectly fine. But remember, what we actually are doing is balancing out the charges. And so there we go. Aluminum oxide. Let's keep going. Let's try out this. Let's try iron 2+ and sulfur 2-. This should be pretty simple, right? We already have 2+, 2-, Fe, S. So there we go. That's going to leave us, that's going to be it right there. Iron 3+. This is now iron 3+. Remember, those transition metals can switch up their ions. Iron can actually be 2+, 3+, or 6+. And you don't really know what's what unless you're told that. You can't just say iron sulfide and know which one it is. Is it 2+, 3+, 6+? But what you can do is look at the chemical formula. So this one is for 4, and for 5, We have 3 plus and 2 minus. We can do the same trick as before, FES, and just switch swap. 2 for the iron, and then 3 is going to move over to the sulfur. So one thing you can do is if someone says you have an iron sulfide compound, an ionic compound with iron and sulfur, and they give you this chemical formula, you know that sulfur is going to be 2 minus. You can look in the periodic table, sulfur, it's right here, 2 minus. And so if it's FES with no subscripts, you know that this is going to be 2 plus. You can kind of do what we've been doing just in reverse. Here, I know that this is 2 minus, so 2 minus times 3, that's 6 minus. So we need 6 plus in order to balance it out. And since we have 2 irons with 6 plus, that's going to be 3 plus. So now I know that the charge of this iron ion is 3 plus. So there's that. All right, so that's the skill I wanted you guys to learn today. What I am going to do is give you guys a worksheet to do. It's going to be pretty simple. The worksheet is basically just going to have a bunch of compounds. Then you tell me if they are ionic or covalent. Remember, ionic compounds, just like these that we've been working with, are a metal and a non-metal, right? Covalent compounds, like H2O, are going to be a non-metal and a non-metal. If I can make an N, there we go, non-metal. Not 2 non-metals, this is going to be your covalent. Whoop. There we go, that should be an L. Covalent. These guys are your ionics. There. All right. That's it for today, guys. Hopefully you guys are enjoying distance learning, and I will see you again tomorrow.